So we've got a pattern. All right. Now, right from the beginning, I've said to you, got to think about how a pattern is created, yeah? Remember in the book it says find the root of the pattern and then figure out how to move from one to the next, yeah? So we can do that using the pattern and think, right, what is happening to go from there? So any ideas what's happening? How do I create the next one? How many? Three more, isn't it? Alright. So each time, right, if I highlight, so look at the first pattern, alright, and then the difference is these three get added to it, yeah? And then the next pattern is this pattern, but these three get added on. Now, here's what hopefully you're doing. So we then look at this one and we say, actually, look, it starts with a 3 as well. All right, so the root, actually, the thing that stays common every time is the 1 on its own, right? So we've got this 1, we've got 1, we've got 1. Okay? Yes, Michelle?
I was just saying the way I did it, though, is it adds 1 on the top, middle, and bottom of each one.
Okay, but to simplify that, 1 top, middle, bottom, to simplify it, you add 3 on to the side. Yeah? So instead of add 1 top, 1 bottom, 1
The right hand side.
add 3. Does it matter which side it's added on?
So we added on it?
Exactly. We could have just said, just add 3 more rectangles, or hexagons, sorry. Alright? Add 3 more hexagons to contain the pattern. So, think about that. Alright? And then what we were doing was we were saying, right, can we express this as numbers? So the first one was 4. The second term was 7, 10. And you could see that our adding 3 on every time, we add 3, yeah, with the numbers. So add 3, add 3. So even without drawing the next pattern, I know the next one in the sequence will be 13 because we add 3. Yeah? Exactly. Super, right. Now, this, guys, this is what we might call a term-to-term rule. The term-to-term rule is how do I get from the previous term to the next one? All right? That's relatively easy, I think. Yeah, you've kind of all done that. All right. Just what we want to do. Yeah, go on, Des.
Do we write the bottom bit or do we write the
Well, I'm hoping you've kind of done that before, yeah? All that's kind of done and good. It's all, yeah, easy enough. Right, if I look at the textbook, which I kind of have been doing, all right, this is all the kind of stuff you've been doing. So you've done all that, how it's done. Then you represent patterns with expressions. So you've kind of done an algebraic consistent variable 4y. What does 4y mean? Right? 4 times something, yeah, anything. Whatever number you pick, multiply that number by 4. Yeah? The second one means whatever number you pick, subtract 10 from it. The subtraction has to be done in the right order. The third one is whatever number you have, whatever number you pick, you have to divide it by 2. The fourth one is whatever number you have,
multiplied and add 5.
so multiply by 3, then you add 5 to it. So that's how we describe it in words. Yeah? Alright? Now this way of describing, remember I said it's about algebra as a language in maths, and it's about how you communicate what you want someone to do. Alright? So we don't write all of this, all the words, okay? We write it in nice short maths freehand, like shorthand, which is called algebra. So we don't have to write all these sentences. That's why I like maths and not history, geography, and English, right? I like to be able to write loads of stuff in not much time. I could use your name and express what you're doing in front of me, couldn't I? But I'm recording, so I'd hate for your parents to watch YouTube and go, oh, really? Is that what? Bear that in mind, because I'm not going to cut this video. Don't edit them, I've not got time. All right, next time I'll use your name. All right, so we've got all of this. And then you were asked to be able to, so 3 times a number, you would express it as? 3. 3, whatever letter, yeah. A number increased by 7.
X or whatever number
Yeah.
you want. Add 7.
Add 7, yeah. A number divided by 43. G? Yeah. Yeah. Good. All right. 8 divided by a number, John. This is a few lessons, yeah. Could you not just give it me now, off the top of your head? 8 divided by a number, you just write.
8. Oh. Y plus.
No, I'm on J. 8 divided by a number.
8 divided by.
And how do I write divided by?
Y.
No.
No.
No, it must be the 8 on the top.
And then. Oh yeah.
Then the divide. Then
Y.
Y. Okay. You must have, right? Increased means add. Right? You can put add in either way around, yeah? Not a problem. Multiply, do it either way around. But we do have a convention that says you put the number before the letter. We have 3 X's, we don't have X3s. Alright? But reducing by 13, you subtract 13. You don't do something subtracted from 13, do you?
No.
Reduced by 13. That way. Division, if I divide by 2, it means I cut something into 2 pieces. Yeah? It's very specific. It has to be done one way. So the subtractions and the divisions must be one way. I hope you are all good with that. Okay? Working on, so translate the following. I think you're good with this. So H, J divided by 20 add 7 means, here?
Y.
Now J
Oh, sorry.
divided by 20 plus 7.
What
What does it mean?
to subtract.
Nope. You know which one I'm looking at, yeah? This one?
No, we're looking at H. I thought we were looking at.
So I said H. J divided by 20 plus 7. What does it mean I'm doing in words?
H is a number as the numerator and 20 is the
No, I want it in English language.
A number divided. A number divided by 20 plus 7.
Okay. What do we say instead of plus?
Add. I'm sorry. I forgot. It's not reduced. Added. I know. Added.
Could be added. Increased. There you go. You jumped in. Yeah. You divide the number by 20 and you increase it by 7. I'm happy with add 7 to it, something like that. But don't just say plus 7. If we're saying it full language, I have a number, I must divide that number by 20, then I will add 7. So we say it in full. Here?
I kind of messed up because I thought I wasn't thinking of J. Divided by 20, I was a number divided by 20, I was thinking of a denominator.
Okay. But in terms of, you get the language thing I'm talking about now. Right? This one, would it be the same if I said, have a number, then you add 7 to it, and then divide by 20?
No.
Good, right? Order of operations, right? Doesn't mean the same thing.
Would be a different number.
Would be a different answer, yeah. Right, so, generalising a pattern. We've got this, goes up plus 4, yeah? The term to term goes up by 4 every time. It's a linear pattern because, Emma? Perfect. Goes up by the same thing. This is linear because it's always add 4. If it's not always add 4, it's not linear. Okay? All right. Each of these secrets, find the next term and the pattern rule. So we know 38, 34, 38, 44 is always add 6. Yeah? All right, so we're all good. Now, where we are going to move on to, okay, we're moving past a lot of this. If you've got all that to do, I don't give you homework for the reason that if you've got catch up. All right, you can do that on your side, you decide what you need to do. All right, we did the substitution thing. Right, that was good. You just put the number in for the letter, replace it, and then work it out, yeah? Any questions on that? Is all good?
No.
Good? Right. Anyone got a question now in yours? Karen?
I was really bad at this.
Okay. Why were we bad at it? In what way?
I started doing it wrong, so then I had to go back.
But now you're doing it right.
Yes. And also, number 2, I did a couple of
Okay, some of the hard. Number 1, I was hoping. What do you think?
I wasn't here when we did this.
Okay.
So,
Des?
I was just confused from question 3.
Okay. Well, those get harder, you're right, but question 1.
No, I mean, from practice 3, question 3, all the way to, I did practice 4, question 1, and then we got confused.
All right, so this question, this is what I'm most focused on at the moment. All right, the worded questions, we can come back and work them out. They are harder, okay? But this one was quite important, right? Shall I go through a couple just quickly? All right. Let me just go through it just quickly, because I think it's actually quite easy, but everything's easy once you've been told how to do it. Okay, so I'll do a few. All right, let me. What's up, Tristan? Hurry up. Right, so let's just talk this through. Substitution, what it means is, what does x plus 7 mean? Right? Rocco? Well, before the 3. A number plus 7. Right. X plus 7 just means think of a number, add 7 to it. Increase it by 7. Now, the next piece of information they're giving you is that the number that you are being told to use is 3. X is 3. So we can substitute that back in. This is a super important thing with maths, by the way, substitution. We can substitute, just like you would do in a football match. You're with us? Remember what I'm going to say? I'm going to put it away and concentrate. Yeah. You replace one thing in maths with something that has equal value. And what sign means equal value? See? The equal sign, yeah. This sign means that and that are interchangeable. They're the same thing. All right? Therefore, x plus 7 means the same thing as 3 plus 7. It's the same thing. All right? Therefore, the answer is 10. All right? Make sense? If I change x to a different number, I change the answer, yeah? And that's, yeah, so C, something, take away 10. Well, if I tell you that the something has to be 23, then this is going to be 23 minus 10, which equals 30.
Oh, I thought it was the other way around.
Well, that's the thing, isn't it? You must not, and a couple of you do this, just write subtraction any way you like. Because, for instance, if I say I'm going to reduce the money in your pocket by $10, all right, you are expecting me to take $10 away, aren't you? It wouldn't make sense for me to say, you've now got 10, I'm going to subtract 150, because that's what you've got. Like, no. And that makes no sense. Subtraction has to happen one way, right? I have to subtract 10 from the number, not the number from 10. And that just takes an extra thought All right, so that's C, that's A. Should we do F? How are you feeling about this? Does it make sense?
Yeah.
So I am now told that G divide by 2, then add 13 to that result, okay, is what I'm being told to do. And then I'm being told, right, do that when G is 8. So I'm being told G, in this case, is 8. So what do I have to do? Should we go? Go on.
So first we do the 8 divided by 2.
Yeah. Now I'm going to write it as 8 divided by 2, still add 13. Okay. And your next step is to say what you were going to do, which is
Add 13 to.
well, we'll have to do. You were going to do 8 divided by 2 first, weren't you? Which is 4. Then you do 4 plus 13 makes 17. Okay? So we had to do it in the correct order because of FODMAPs, yeah? Make sense? All good? Brilliant. Ready to move on? I thought you guys were good at this. Right. Now, the next, so there's lots of, these are all basically just harder worded questions, and we'll come back to these. All right? What's hard about these is not necessarily the maths, it's about taking the information out of the words that you need. All right? Yeah, exactly. And we'll work on that, because these are kind of like our criterion C and B type problems. So this would be an ideal topic to be doing a criterion B. All right? So what we're going to now work on, okay, patterns as functions. All right? Don't worry about it just yet. All right? Don't worry about it just yet. I'll tell you what page it is. All right. So what does this mean? There's one fundamental difference to the approach we're making now, which is, all right, we go back to our pattern. All right. This time, we're not doing a pattern as in term to term. All right. We already did this with the pattern, so I know that this is the first term, this is the second term, this is the third term, this is the fourth term. If I asked you for the fifth term, you would just tell me it's 16, right? Now remember, because you guys were on it quite well, if I then said to you, what's the 10th term? All right? Yeah?
16 times 2.
No. You did that last time. It's not. You don't double, well, not all the time, it might happen. So you don't just double the 5th to get the 10th. Right? You have to think about how the pattern is going. Yep. Would it be 30? Why?
Because if you keep adding 33 times 10 is 30.
Okay, you got an idea, but I don't know, is that going to work? So that should also work, that the 10 lots of 3 makes 30, but 3 lots of 3 doesn't make 10. 3 lots of 4, or 4 lots of 3 doesn't make 13. But you are getting very close.
3 times something is right.
What we do you remember we thought about it? Max? No, you don't need to. Listen to me. You find anything you can do to not pay attention. Alright? Do you remember what we did was we said, how many lots of, that's why I coloured the 3, how many lots of 3 are there in every term? So there is 1 lot of 3, 2 lots of 3, 3 lots of 3. So you're right in terms of the 10th term could be 10 lots of 3, but, okay?
It's 31.
Why?
Because the 4, you don't start on 3. You start on 4. So like since 4 is one more than 3, the 10th time off.
Okay, so when we look at it and how it's structured, we have got 10 lots of 3, but we've also got the root of it, which is the +1 on every time, yeah? So the 10th term is actually 31. And then we could say the 100th term is 100 lots of 3 plus 1. So it's 301. Right. You've basically done everything we need to do, but we need to sum it up and bring it together. So, what we're going to do is we are going to write what's called a rule for this pattern, okay? But it's not going to be a term-to-term rule, it's going to be what we call a general rule that helps me find any term from its position. And the rule for this particular one is 3n plus 1. Why? Right?
Well, because you don't know what term it is, but you know they have to multiply it by 3 to reduce 3n. And then you also know that that thing that stays the same every time, so you just add it.
Yeah. So this bit here tells me how many I add on every time. And I can get that from this number, because I know 3 gets added on every time. And as long as I know what this extra bit every time, I can just add that on. Does that make sense? Alright, so we only have a couple of minutes. So can I get you to write this down now, and then next lesson we can move on and do some more.